I would be discussing the paper that I want to try to upload right now. Okay, so I believe you can see the paper that we're going to be discussing. So basically the paper talks about method validation and evaluation of household processing on reduction of pesticides residues in tomato. So the whole idea or the whole essence of this paper is to show that one, tomatoes have insects that eat them, and in order to minimize the effects of those insects, there are certain pesticides that are used. And even though some methods are used to clean up our fruits before we eat them, those pesticides don't really go off. They are still there. So this study is trying to use some sort of standard methods, validation, and also evaluation to show different household processes that can reduce these pesticides. So I would say, as a form of introduction, that the study followed some validation parameters or measures of text accuracy with a prescribed analytical method in the laboratory within a prescribed limits and defined standard. Secondly, in the paper, a blank tomato matrix was spiked with the pesticides at different concentration levels of 5, 10, 25, 50, and 100 micro 100 micro, let me check value, sorry about that. Uh, 100 microgram per kilogram in 5 replicants. And also there are two terms that we need to be aware of. The first one is the limit of detection, which checks the lowest amount of the analytes, that's the pesticide that can be detected but not quantified, while the limit of quantification checks the lowest amount of the analyte that can be detected but quantified. So on this table, we were told that the limit of detection for the first pesticide, which is metalaxyl, was 0.01 for chlorpyrifos. Chlorpyrifos was 0.003. For limit of quantification for metalaxyl, it was 0.03. For chlorpyrifos, it was 0.009. Another thing that we also have to appreciate in this work is that the samples were treated, as mentioned by the authors, according to what they call catchers, which is spelled QUE and CHEROS, and it's a sample preparation technique predominantly used for the extraction of pesticides and other contaminants, and it has an abbreviation where the Q means quick, E means easy, the C means cheap, E means effective, and the R means rugged, S means safe. All right. Now in this table, this is more like the table one is more like the baseline table where all the parameters were sort of validated to show that they followed a standard prescribed method or a defined standard that is acceptable anywhere. All right. So using the limits of detection that is acceptable, using the limits of quantification that is acceptable, and also they did some sort of fortification level. The fortification level would also mean the spiking process, you know, which involve, like I mentioned, the tomatoes being spiked with pesticide at various concentration. So they show that, and also they show the recovery and the precision. The recovery being the how much of the amount of the analytes that will be recovered by the proposed analytical method after the spiking. So we have spiked the tomatoes with the analytes, that's with the pesticide, and they also want to check how much of that analyte that will be recovered, meaning that at this baseline, they should expect a higher proportion of the analytes to be gotten back. So for the tomato, they got about 99.4%, which is good, and 95.3%, which is good. For the chlorpyrifos, they got 101.7%, which is good. So the recovery percentage is good. And also the relative standard deviation, which it's a form of statistical method that measures the precision of the process in percentages. In other words, the smaller the relative standard deviation, it means that the less variation, the less variability, which is also needed to prove the standardization of the process. So we have 7.2, 10, 11.3. So all these are actually small percentages that shows that there is minimal variation in the process. So if you look at this table one, I think what they've done, they've tried to show us the baseline of the validation process. And whatever values they got here is more like a standard value to show that the analyte that they had put into these tomatoes, they can recover majority of them, because this analyte were sparked, more like it was imputed, infused. So the validation for the process of what they want to do is good from the table one we have seen. And also in this table two, they did something like a linearity test using the Pearson's correlational coefficient, which has a range value between 0 and 1. 0 means poor correlation, 0.9 or poor correlation or weak correlation, while 0.9 and 1 means very strong correlation. So very strong correlation means that as A is increasing, B is also increasing. But any correlation, any arrow that is less than 5 is poor. Anything that is above 5 is strong. So in this case, they did a correlation between the solvent extraction and the tomato matrix to see if, as this is increasing, solvent extraction is increasing, the tomato matrix should be increasing. That way you can say for sure that the analytical method is acceptable and validated. And that's what they did in table 2. And the coefficient metric, the coefficient matrix here is 0.99. The arrow square means the proportion. So it means that almost 99, almost 1% of the solvent extraction is correlating with the tomato metrics, which is good. So it will have some sort of linearity curve to show that the analytical method is acceptable and validated. So table 1 and table 2, it's only validating the process to show that the method that they are using is a standard method. The real analysis begins in figure 1. So like I had mentioned to you, the researchers spiked some tomato juice and they want to know which of the processing treatment will reduce the pesticide in this tomato. So the first processing treatment method they used was juicing and popping of raw tomato. You know, juicing and popping of raw tomatoes, what really happens is the external part of that tomato is not used. It's only the internal part of the tomato. Then they blend it and turn it into a juice, or popping. They just ground it. Then the second thing they did in the processing was washing. And they did 3 kinds of washing. They washed with water in the group 1. They washed with sodium carbonate in the group 2. And they also washed with acetic acid solution in the group 3. And finally, the hydrogen peroxide in the group 4. Then they also did sonication. The sonication, which is the process where ultrasonic cleaner is used. So that one also has 3. The group 1, which is for 15 minutes, the group 2, which is for 30 minutes, and the group 3, which is for 60 minutes. So these different groups are the processing treatment. So their goal is to see which of these processing treatment will cause a good reduction in the 2 pesticides that are used, which is the metalaxyl and the chlorpyrifos. So let us look at the analytical tables now. The first one is this, which is the first treatment. The first treatment is in figure 1. If you look at these, you would see this is the pulp and the juice treatment. The pulp and the juice as a form of treatment. So at this first part, you have the raw tomatoes, then you have the pulp, and you have the juice. What this shows is that in the raw tomatoes, there was a very little reduction, as you can see, very little reduction in both the metalaxyl and the chlorpyrifos. But in the pulp, you will see that in the metalaxyl, they were around 80 or about 80 or 80 something, this 0.8. In the note, it says 88% of reduction in this first pesticide and about 39% reduction in chlorpyrifos. For the juice, you will see that the reduction was higher, about 66% in metalaxyl and almost 98% in chlorpyrifos. So in this table, we can see that where the reduction happened most was in the juicy form in the first treatment, compared to pulp, and followed by the raw tomato, which had the least reduction. So secondly, we will look at the table 2. So table 2 looked at the second treatment that has the various washing techniques. They had a control. The first one is they washed with tap water, then acetic acid, then they also washed with sodium bicarbonate and also the hydrogen peroxide, 1% hydrogen peroxide, 10% of the sodium bicarbonate, 4% of the acetic acid. Now let's look at the effect of these different processes on the two pesticides that we're looking at. From the result, you can see that the tap water has about 19% reduction in metalaxyl and also 34% reduction in chlorpyrifos. The acetic acid has no reduction at all in metalaxyl, but about 39% reduction in chlorpyrifos. For the sodium bicarbonate, there is also no reduction in metalaxyl, but about 41% reduction in chlorpyrifos. And finally, the hydrogen peroxide, only 2% reduction here, but about 45% reduction in the chlorpyrifos. So that is the level of reduction for the washing experiment. Now let's look at the third figure. Now this is the third figure, which is the third treatment where an ultrasonic bath is used. There's a control and you have 15 minutes, 30 minutes, and 60 minutes. You will see from these that the chlorpyrifos was completely gone in the 60 minutes. It didn't exist anymore in the 60 minutes, but in the 30 minutes, there was about 94% of it. And in the 15 minutes, you will see there's about 30% reduction of it. But the metalaxyl reduction was not as much as the chlorpyrifos. As you can see right here, in the 60 minutes, you had like 23 reduction, which is not much in the 60 minutes for metalaxyl compared to chlorpyrifos where everything is gone. So from these three tables that have shown us, the first one, which is the pulp and the juice, the second one, which is the washing experiment, the third one, which is the ultrasonic bath, we will see that the reduction effect for chlorpyrifos is stronger compared to metalaxyl. And the final table looks at the processing effects. All right, the processing effect, which indicates a reduction or not in the electrolytes or in the analytes that is used. So if you look at these processing factors, you will see that there is a strong reduction in the analytes in the juice. If you see, in the juice is about 0.34, that's 34%. 34%. If you check for the chlorpyrifos, you will see it's very small, about 2%. So for the juice, you will see that the reduction is very high, followed by the pulp, which is about 0.51%, for the metalaxyl, and 29% for the chlorpyrifos. So from these processing factors, we can see that the reduction in the analyte or in the pesticide was higher in the juice, followed by pulp. For the washing with water was lower, 81%, and 66% compared to other washings. Other washings were above 1. And also for the sonication, 60 minutes seemed to be higher in terms of reduction, 77%. So sonication for 60 minutes the reduction was higher, more compared to even washing with water. All right. But at the end of the day, the one that has the most reduction is the juice. So now these are the three tables. So if we want to make a conclusion of this, we can say that between the pulp and the juice, the washing, the ultrasonic, I think the figure one has more reduction compared to the others. That means when these tomatoes, their skin is removed and they are used as juice. And it's understandable because when these fruits are treated with pesticides, the pesticides are usually on the skin of the fruit. So it's understandable that when the skin of the fruit is removed, that there will be some form of reduction in the pesticide. That's why the chlorpyrifos has more reduction than the metalaxyl. Reason being that the metalaxyl is a systematic pesticide, meaning that it is water soluble. And being water soluble, it means that metalaxyl as a pesticide can actually infuse itself inside the fruit. It can go beyond the skin and enter inside the fruit, unlike chlorpyrifos, which is non-systematic pesticide. Chlorpyrifos stays only on the skin of the fruit. It doesn't go inside the fruit. That's why if you take a process of juicing and popping, which involve removing the skin, it's understandable that we could have a significant reduction in the concentration of the analytes or the pesticides seen here. Now, from the way this paper is structured, I do not think that the authors really have plans in using some statistical method per se to actually infer on our results, because if that is really the purpose of this, definitely from every of these tables we would have been able to see some statistical method. Although if you go down in the paper, somewhere around here, there are some statements that were made about statistics, but not very clear. Like here, they said here, both carbofuran and phenobucarb residues were reduced by 58% and 40% respectively, although without statistical significance. Now, I didn't want to go ahead and start checking carbofuran and phenobucarb residues, because what I know is that what I should be hearing in this case is the pesticides that are used, which is the chlorpyrifos and the other one. So this chemical which is here, I don't know what they are. I don't really know how they relate to the study, but it could mean that these two chemicals are in one of these pesticides or in both of these pesticides. So it is not clear which one. But if the pesticide themselves were used here, then we would have been able to tell what they were referring to. Even in the second part, it says, however, there was no significant difference between the mean concentration of pesticides after washing versus unwashed sample. Now they mentioned the mean concentration of pesticides. So I don't even know which of the pesticides. We have two pesticides. So here, however, there was no significant between the mean concentration of pesticide after washing versus the unwashed. So I don't even know which of the pesticide they are referring to. So you see, even the little statistical inferences they wanted to make in the paper were not even clear, which could also prove further that the goal of this paper is not to prove any statistical inferences. But if I have to use statistical inferences on this paper, what would that be? Now, what they use to tell us the reduction in the pesticides were percentages of this concentration. Like for the first treatment, which is the pulp and the juice, they told us that for the juice, there was a 66% reduction in metalaxyl, and there was a 98% reduction in chlorpyrifos. So what I would do as a statistician would be that, is there a statistical significant reduction between these two pesticides in juice? Is there a statistical significant reduction between these two pesticides in pulp? And is there a statistical significant reduction in these two pesticides in raw tomatoes? That's what I would have done. And because the reduction was stated in percentage, the best statistical tool I would have used in checking for difference in proportion is the chi-square. So I would have done a chi-square here in the juice between the 66% and the 98%. The reason why I am doing a chi-square between the 66% here on top of the metalaxyl found in the juice and the 98% on top of the chlorpyrifos found in the juice is to know whether 98% reduction in the chlorpyrifos is statistically significantly higher than the 66% reduction in metalaxyl. So if I do that and I get a p-value less than 0.05, it means I would be able to say of assurance that juice treatments in reducing pesticide in tomatoes is significantly higher for the pesticide chlorpyrifos compared to metalaxyl. Now, I could do that for pulp also. I could do that for raw tomato also. Now, even if I do that, the only challenge I may have in this is the fact that the two pesticides that were used in this study were not the same. Metalaxyl is a systematic pesticide, meaning that it is water soluble, it is absorbed by plants. But the other one, the chlorpyrifos, is non-systematic, meaning that it is easily washed away. So now, even if I use this statistical method to actually check if the reduction in one is significantly higher than the other, I would not have the strong liberty to actually infer that, because I didn't use the same pesticides that has the same systemic properties. So that is one of the challenge that I have with this study. Because even if I use the statistical method, like I mentioned before, to prove that there's a significant reduction in chlorpyrifos compared to metalaxyl, it's really supposed to be so, because chlorpyrifos is only on the skin of the fruit. So it's understandable that when you do anything that will remove the skin of the fruit, you would have less pesticide. So one of my recommendations in the study, I don't know how many pesticides are there or what type of pesticides are in the market, but for this study to be truly accurate from my own end, I think they would have used pesticides with the same property. Pesticides with the same property. That way, I would be able to know which of this method will cause more reduction than the other. Now I can't tell, because already the chlorpyrifos is at a disadvantage because it doesn't even enter the fruit, it's at the skin. So once I remove the skin, it goes away. That is why you will see that in every of the figure, in figure 1, in this figure 2, and even in figure 3 during the ultrasonic bath in the 60 minutes is not even there at all, because by the time you bath this fruit for like 60 minutes, that means you have overwashed the skin, so that pesticides will not even be there. But what about the metalaxyl? So what will happen to the metalaxyl? So if we don't consume the chlorpyrifos, what about the metalaxyl? You know, so what this research has ended up doing is to show us that any non-systematic pesticide would be easily washed away by these three processes. But any systemic pesticides will not, because the systemic pesticides seem to be gaining more weight. You know, irrespective of the process that was used, the reduction is very minimal to have a significant impact. All right, but for the chlorpyrifos, yes, it's high. So looking at this study, really, although the conclusion would say that there is some percentage reduction of this pesticide over this pesticide, I still feel that these three processes that were used, there is no much significant reduction in terms of the pesticide, as I mean for metalaxyl. So my inquiry to the authors would be that apart from these three methods that have shown some level of reduction but very minimal, is there other methods that can be used? Because the metalaxyl is still shooting high in almost every one of them. So meaning that the three methods did not have much impact on the metalaxyl. But yes, for the chlorpyrifos, they did. So that is what I would love for the authors to clarify. But in terms of the statistical part, if I really want to see if the reduction, like I mentioned before, the percentage reduction is significantly higher in one compared to the other, the best test to use in this case would be the chi-square, because they are talking about proportion in this case right now. I think for this study, that is the only form of statistical test that would be used, because anytime you're talking about reduction or increase in percentage, you would be using a chi-square to check for that difference in that in the proportion. So and there's something else the authors, they said here, if you look at this conclusion, I don't think it's correct from what we've seen so far. They said the percentage reduction was lower in metalaxyl than in chlorpyrifos. You agree with me that from what we've seen so far is the other way around. So I don't know if this conclusion here is accurate. You know, I think that is basically it for the study. So like I'd mentioned, this study is purely a laboratory and purely a clinical study. So I don't think the authors have in mind to really apply statistical principles on it. But if peradventure it's my study and I would want to apply, that is the only test that would be applicable for this kind of research, which is a chi-square, to see if the reduction in one pesticide is significantly higher than the reduction in another pesticide. Because right here, we are saying that the reduction, especially for the treatment, which I always use as an example, is very high. For the pulp, for the juice, the chlorpyrifos, the reduction is very high, but is it significantly higher compared to the metalaxyl? That is what our chi-square test would have answered. That way it will make the study more interesting. So I think that is basically all I have to present in this work, because the work doesn't have much statistics on it. It's purely clinical. All right. The only concern I have is what I've mentioned before, that the two pesticides that are used are not the same. And so it is understandable why the chlorpyrifos will have much reduction compared to the metalaxyl, because the chlorpyrifos on its own is non-systematic. It doesn't absorb into the fruit, it stays on the skin. So even water alone, just using water to wash the fruit, like we have seen here, will have some significant reduction, compared to the metalaxyl. So I think that is so. If anyone have a question regarding the statistics, you could ask, but in terms of the experimental process, I may not be able to help you with that. Thank you very much.
Thank you, Felix, for
Yeah.
your time in going through the article and pointing out some of the observations you've made. Any question from anyone? Is there anybody with any questions? We don't have questions, then we can end the meeting.
Oh, someone was saying they can't hear me. Is that okay?
I think that has been sorted out.
Okay. Check your audio. It seems you are only one. Okay. So there's no question in terms of
Question, comments?
yeah, although the paper doesn't have much statistical, so I understand if anyone would not have much, but like I
Samuel,
had.
do you have any comments? Samuel? I know you had reviewed that paper on WhatsApp.
Yes, if
Yes.
you read this paper and you look at it, probably from the statistical point of view, and by looking at the values, those figures, you would maybe assume that the analysis was done on a single sample. The reason I'm saying that is because if you look on the bars,
Yes.
Yeah.
there is no any standard deviation.
Yes,
no
I noticed that too.
error
Yes.
expressed on those values.
Yes. Yeah.
So it gives you very little reliability on what was done.
Okay.
But in generally, yes, but because the method used here are also common, you try to think what was really the aim of this, you get lost.
Yeah.
What did the authors really want to do?
I was actually avoiding coming from this angle
Because
it's recorded, so I tried.
yeah, maybe what I should say on the two pesticides is that I would agree with the authors to analyze the two pesticides by using those methods they used. And I think it is applicable because these pesticides are used in tomato field, and although they didn't mention how much they are used in the real field, but at least because they are in the market, it is okay to analyze that way, regardless of their differences and properties of the pesticides. I'm referring to some other studies. When you try to read the literature, they also use some different chemicals with different properties, just to show that a certain method can work for one pesticide or pollutant, but it can't work for another. So they generate this kind of knowledge that if you have this kind of pesticides or pollutant, of course, by using these methods, you will reduce. But if you are pollutants of this do have these properties, then it is not helpful to use these methods. So in terms of science, it's okay. You can have different pollutants which differs in properties and then use some similar methods
Okay.
to see what you can do to reduce the pollutant for human health.
Okay. All right.
Yeah, that is what I can say about this paper.
Thank you, Samuel. Any other comments? Murtala, Ibrahim, Damilola, Annie, Sabita.
And you know, Dr. Fumi.
Yes.
Yes, and you know, he made a point that I also raised. You know, from
Samuel?
the various yes,
Okay.
yes, from the various methods that they use, you will see that there is more reduction in the chlorpyrifos. And for me, it may be like it's a coincidence, like may not necessarily be because of the method. I'm sorry, because the systematic side is on the skin. It doesn't enter the fruit.
Yeah.
And so just using ordinary water will cause a huge effect on it. So the main one that I'm really concerned about is the one that enters the fruit.
Oh, yes.
And the three methods really showed no significance. So I'm like, I mean, there's no reduction. So which method will I use that will reduce the systematic pesticide? I'm not interested in
and that's the most important one.
Yes.
When it comes to toxicity, because it's being consumed by humans.
Exactly. So you didn't show me how to reduce the systematic. So I mean, so like you said, you know, sometimes it's not easy to really get the goal of the paper. You know, like I mentioned.
I'm sure somebody else that is interested in this can do further research.
Yes.
Consider
yes.
some of the points that have been raised.
Yes.
This paper. It's a good work. Yes.
Yes. Especially the validation aspect. They did, you know, following that. I mean, it's not my field, but I would give them credit for using all the standard validation method in the work. So that's really good, especially that you know, I've forgotten what they call it, the catchers. You know, I had to read about that. It's a very long. It's great to see that.
Thank you, Felix. Thank you.
Yeah.
Do we have any other comments? Ibrahim, Murtala, Annie, Sabita, Damilola, anyone? I think it's almost an hour. We spent almost 1 hour. So if we don't have any comments or questions, we can end the meeting then.
Okay.
Right. Okay.
Thank you, Dr. Fumi. Thank you.
Thank you.
Thank you.
Thank you for your time.
Right,
Bye.
Bye-bye.
Bye-bye.